Hello and welcome to GED Mathematics Live at PALS. In this video, I will be talking about functions. As we look into functions, we will be going through evaluating functions, recognizing a function from a table or a graph, identify when a graph function is positive, negative, increasing, or decreasing. And we will be determining the period of a function from a given graph. To continue, let's proceed to evaluating function. In evaluating function, all we need to do is plug in the value of the input into the expression. For example, if f of x is equals to x squared plus 1, find the value of f of 3. It means when x, the input, is equals to 3. So again, all we need to do is plug in the value, the given value of the input. So if f of x is equals to x squared plus 1, then f of 3 is equals to 3 to the power of 2 plus 1, then simplifying, 9 plus 1 is equals to 10. So the value of the function when the input is 3 is equals to 10. Another example, if f of x is equals to 6x to the power of 2 plus 13x plus 5, then f negative 4 is equals to A, negative 143 or 143, B, 49, C, 81, D, 153. Again, all we need to do to find the value of the function is to plug in the value of the input. So we have f of x is equals to 6x to the power of 2 plus 13x plus 5. F of negative 4 is equals to 6 times negative 4 squared plus 13 times negative 4 plus 5. Following the order of operations, we have 6 times 16 minus 52 plus 5, and then 96 minus 52 plus 5. The value of the function when x is equals to negative 4 is equals to 49. So the answer is letter B, 49. Now let's proceed to recognizing functions. Now before we go through recognizing functions, let us first define what a function is. Because in recognizing a function, you need to know what a function means. So it says here, a function is a mathematical rule that relates an input to exactly one output. Then this is the function. F of x is equals to x plus 5. F is the function name, and x is the input. Then x plus 5 is the output. Again, a function is a mathematical rule that relates an input to exactly one output. In the table, y is the value after a rule of f is applied to x. Based on this, is f a function of x? Let's check. When x is negative 1, y is 0. Again, when x is negative 1, the value is 2. Now, based on the definition of a function, If we go back, a function is a mathematical rule that relates an input to exactly one output. So here, for one input, there are two output. So therefore, y is not a function of x. Another, does the table represent y as a function of x for the given values of x? Let's check. When x is equals to 5, the value of y is 2. When x is 6, the value of y is 3. And when x is 7, the value of y is 4. So, for each value of x, there is only one value of y. So therefore, the table represents y is a function of x. Now, how about a graph? Determine if the graph represents y as a function of x. Now, for a graph, there is what we call vertical test. Okay, vertical test. Vertical test is a vertical line that we use to check if in each values of x, there is only one value of y. However, in this graph, when x is 3 and more than 3, there are two values of y. So therefore, y is not a function of x in this graph. Let's look at this given graphs. Okay, as we look at the graphs, there are parts, there are value of x that have two values of y. So therefore, these graphs is not representing y as a function of x. How about this second graph on the right? For each values of x, there is exactly one value of y. At first, it looks like there are two values of y. However, the other one is an empty dot. So therefore, or an empty circle. So therefore, it's not included. So one value of y. So therefore, this graph represents y as a function of x. Okay, some other examples is on the screen. Okay, the first on the left represents y as a function of x, and on the right, y is not a function of x. Let's try an example from a GED question. Okay, in the figure shown, for which of the following ranges of values is y a function of x? Let's check. Letter A. 0 when x is greater than 0 but less than or equal to 2. So A, using a vertical line test, A does not represent y as a function of x. Letter B, x is greater than 2 but less than or equal to 4. Okay? Okay, checking from 2 to 4, there is only one value of y for every value of x. Letter C, no, because there are two values of y. For D as well, there are two values for y. So the answer, and the only answer among the choices, is letter B. When x is greater than 2, and less than or equal to 4. Now let's proceed to intercepts. Okay, identify any x-intercepts in the graph of a function of f of x. Okay, when we say x-intercept, this is the point where the graph passes through the x-axis. So checking the graph, okay, we have 2 points where the graph passes through the x-axis. The first one is -3, and the second one is when x is 3. So -3 and 3 are the intercepts or the x-intercepts of the given graph. Another one. Following is a table of values for a function f in a graph for another function g. Based on this information, which function crosses the y-axis at the highest point? So it means we will be comparing the table for f and the graph for g. And it says, based on this information, which function crosses the y-axis at the highest point? So when we say y-axis, it means the value of x is 0. So from a table, when x is 0, the function is -3. Then looking at the graph, when x is 0, the value of the function is 2. So therefore, function g crosses the y-axis at the highest point than function f. Let's proceed to increasing and decreasing functions. Okay, how to determine if a function is decreasing and increasing. First is, if the graph is sloping upward from left to right, it means the slope is increasing. However, if the graph is sloping down from left to right, it means the slope is decreasing. Now, if you are looking at an equation of the line, usually if the slope is positive, then it is an increasing slope. If the slope is negative, it means it is a decreasing slope. So those are the ways how we can identify whether a slope is increasing or decreasing, or whether a function is increasing and decreasing by looking at the slope. Let's proceed to relative maximums and minimums. Okay, let's look at the graph. Okay, there are parts on the graph that were marked relative maximum and relative minimum. Now, based on the graph, determine over what values of x the function is increasing or decreasing. Also determine at what x values the function reaches any relative minima or maxima. Now, again, let us look at the graph. Now, the function is increasing for x values less than -3. Okay? Where is -3? Okay, -3 is here. Okay? So the function is increasing for x values less than -3 or greater than 4. Okay, 4 is here. So the function is increasing, less than. So from here up to the relative maximum, that is increasing. And greater than 4, from relative minimum going up, that is also increasing. Now, the function is decreasing for x values between what? Between -3 and 4. Okay, from here, between -3 and 4, the function is decreasing. Okay? By the way, to identify whether the function is increasing or decreasing, we should always look at the direction from left to right. Now, the function reaches a relative maximum at x is equals to -3. And the function reaches a relative minimum at x is equals to 4. So when we say maximum, the highest peak or curve of the graph, and we say minimum, the lowest point of the graph. So that is relative maximums and minimums. So from that graph, we can also identify whether the values of the function is increasing or decreasing at certain points. Now, let's understand positive and negative values, especially by looking at the graph. Let's observe the graph. Determine what values of x make the function above positive and negative. Now, as you can see, when x is in between -1 and 2, the values of the functions are positive. Okay? Then, when the values of x is greater than 2 or less than -1, the values of the functions are negative. So the function is positive whenever x is between -1 and 2, and the function is negative for values smaller than x is equals to -1, and for values greater than x is equals to 2, to the right of 2. Now let's understand end behavior and periodic functions. Okay, let's look at these notes. If a graph, then the function value is. So if a graph falls at the right, okay, we are talking about the end behavior, falls at the right, then the function value gets smaller as x gets very large. However, if a graph rises at the right, then the function value gets larger as x gets very large. If a graph falls at the left, then the function value gets smaller as x gets very negative. If a graph rises to the left or at the left, then the function value gets larger as x gets very negative. Let's look at a graph to understand this one much better. Okay, based on the graph of f of x, describe what happens to the value of x or to the value of the function as x gets very large or very negative. Okay? The end behavior is this and this. Okay, those are the end behaviors. Now let's describe it. Now, as x gets very large, the value of the f of x also gets large, right? It means as x gets very large, because from 8 going up, 9, 10, 11, the values of the function is going up. also. And then, as x gets very negative here, going to the left, the value of the function gets very negative as well, because the arrows goes down. Now let's proceed to periodic functions. Now I want you to look at the graph of a periodic function. Okay, if the function g of x is periodic, what is the function's period? Okay, to understand a periodic function, let us define it first. A periodic function is a function that repeats its values at a regular interval. For example, the graph. The values of the function are being repeated at a regular interval. Now, what is the interval of the periodic function? What is the interval before the values is repeated? Okay, if we're going to look at the graph, the values is repeated at 4 interval. Okay? So it means the period of the function is 4. Let's have a GED type of examples. It says the function g of x is a linear function. The table above gives its value for several different x values. If f of x is equal to negative 3x plus 5, then which of the following statement is true? Okay. Now let's look at the choices. Okay. The first statement on the choices is, on choice A is, the value of f of x is larger than the value of g of x when x is equal to 0. B, the value of f of x is smaller than the value of g of x when x is equal to 0. The value of f of x is equal to the value of g of x when x is equal to 0. D, it is not possible to compare values f of x and g of x when x is equal to 0 without more information. Now the value of the function is being compared when x is equal to 0. So all we need to do is find out. Okay, find the value of the function when x is equal to 0 for both functions. Okay, g of x. When x is 0, the value of the function is 9. For f of x, okay, to find the value of the function when x is 0, so we need to plug in 0 as an input. So we have f of x, or f of 0 is equals to minus 3 times 0 plus 5. So f of 0 is equals to 5. So now we have the value of the function when x is equal to 0, so we can compare them now. So let's check from A. The value of f of x is larger than the value of g of x when x is 0. No, because 9 is larger than 5. B, the value of f of x is smaller than the value of g of x when x is 0. Yes, B is the answer because 5 is smaller than 9. So without checking C and D, we know already that B is the correct statement. Okay, that's the end of our video. If you did not understand the parts of the presentations, you can comment below You can comment which part and what particular concept. If you have any concept or topic and you want us to discuss, you can comment it below as well. So if you want to know more about our school, you want to know more about what we do and how we can help you, you can contact us through our website, www.phuketpals.org, or you can visit us on our Facebook, Phuket PALS, or you can call us on 081-417-0978.